Hello everyone, welcome to the MPI session for today, 2nd April 2020, and today we are going to discuss about the pin diagram of 8086 and also about the minimum mode and maximum mode configuration for 8086 microprocessor. So the course outcomes after this lecture should be to understand the basics of 8086 microprocessor pin configuration and to understand the maximum mode and minimum mode configuration for 8086 microprocessor. So 8086 has total of 40 pins and some of which are multiplexed. For example, AD0 to AD15 pins, they are multiplexed both for data as well as addresses. It is provided with one power supply VCC which is of plus 5 volt, and it has two ground pins at pin number 1 and pin number 20. Microprocessor 8086 can operate in two different modes, namely minimum and maximum modes. The rest of the pins will work same, but for pins 24 to 31 there would be different functions for these pins in different modes. For example, for minimum mode they will work differently, whereas for maximum mode they will work differently. So starting with pin number 2 to 16 and 39, these are 16 pins which are used for address or data. As these are multiplexed pins, so these can be used for data as well as addresses. The microprocessor will receive this 16-bit information from either memory or input-output ports, and then it will manipulate the information internally and then send the result to memory or input-output ports through the same pins. 8086 has 20 address lines because we have a 20-bit address for 8086, so it has 20 address lines from which indicates the primary memory, that is the number of address locations which can be addressed. Therefore, as already discussed, it can access up to 1 MB of primary memory addresses. So the data bus and the least significant 16 bits of address bus are shared on the same pins from AD0 to AD15. So these can be used either as an address pin or address line or as pins having data values, right? So this is known as the multiplexing of these pins. So for address / data pins number 2 to 16 and at pin number 39, so these can be used in the following way. For example, if you want to use these pins, then for the first clock cycle of a machine cycle, that is T1, it will send out address on AD0 to AD15. So microprocessor will send the address on these lines during the T1 cycle, whereas in the later part of machine cycle, that is T3, T2 and T4, so for these it will send out data or receive data through these pins. So next pin is the non-maskable interrupt or maskable interrupt pins, and these are at the position 17 and 18. So pin number 17 is for non-maskable interrupt and pin number 18 is for maskable interrupt. So as you all know, an non-maskable interrupt is the positive going edge triggered non-maskable interrupt, and this cannot be disabled or enabled using any software instruction, and it is to be used when there is some situation, emergency situation like power supply fails or emergency shut off takes place. So in that case this interrupt signal would be used, and it is an input pin to the 8086 and it is an active high signal. So whenever there is an external interrupt to the microprocessor, then this pin will be active. So you don't need to tell microprocessor where to branch the interrupt and where to service this interrupt. So it is already an vectored interrupt, so 8086 knows where to branch and to service the NMI or non-maskable interrupt. It also has higher priority than maskable interrupt. If both of them are active at the same time, then this non-maskable interrupt will be serviced first. And for maskable interrupt, that is at pin number 18. So this can be enabled or disabled using CLI, STI instructions. For example, CLI for CLI is for clear interrupt signal, and STI is for set interrupt flag. So these are the instructions which can be used to set, that is enable or disable the maskable interrupt at pin number 18. So next is the clock or CLK. It is pin number 19, and this is used by 8086 for at frequency 5 megahertz. It is generated externally by using IC generator 8284, and it is used at pin number 19 on CLK pin. So this is basically generated by external device. When we'll be discussing the interfacing of this device, this microprocessor, then we'll discuss the 8284 IC. Next pin is the reset pin at pin number 21. Now we earlier discussed clock pin at 19, and this is pin number 21 because pin number 20 is ground pin as already discussed. So the reset pin is used if you want to reset the clock cycle. At least 4 clock cycles would be reset. For example, if it is set to 1, logic is set to 1, then for at least 4 clock cycles 8086 microprocessor gets reset, and if it, which means it will start from the initial state. The code segment register contents will become FFFF, and the register contents will change to 0000H, and after reset, first instruction to be executed will be fetched from FFFF0. So the values for base address, effective address would change, and physical address will be changed to FFFF0, and this address should be present in ROM. So next is the ready pin at pin number 22, and this is also an input pin of microprocessor. If it is set to 1, that means 8086 will perform the normal operation, and if ready input is equal to 0, then 8086 enters in the wait state from the next clock cycle. So it is an active high input pin. So if its logic is 0, then microprocessor will insert a wait state between T3 and T4 clock cycles. So if the ready signal is still at logic 0 when the wait state ends, then more wait state is introduced. So it will tell the microprocessor to wait for the next clock cycle, and it receives input from the 8284. That was the clock generator, right, which will be introduced when we will talk about the interfacing of this device. Next is the test pin at pin number 23. So 8086 has a software instruction called wait. So if wait instruction is given to the microprocessor, then it will check for this pin number 23. If test bar is equal to 0, then 8086 will not enter in the wait state. but will execute the next instruction in sequence. And if test bar is equal to 1, then 8086 will enter in the wait state and will remain in the state till test becomes 0. And this pin is used when 8086 is operating with the coprocessor 8087 or any other CPU. So in ready state, we generate the clock with the help of 8284, which is used as the input. So it will wait for one clock cycle, and for next clock cycle it will check the ready pin value. Whereas for test pin, we have a software instruction which will check the test pin. So depending upon the values given, this will wait for the time till its value becomes 0. Next is the read pin, which is at pin number 32. So this pin is active low output pin. So whenever the microprocessor needs to get the information from any memory location or any input output port, it activates this RD bar or read pin. Next pin at pin number 33 is minimum maximum mode pin. So this pin is if this pin is at 5 volt, then the CPU will enters into the minimum mode, and if it is connected to ground, then maximum mode will be activated. So as already discussed, microprocessor 8086 can function in two modes, minimum mode and maximum mode. So depending upon the pin, this pin value will be either using the 8086 microprocessor in minimum mode or maximum mode. So minimum mode is when you are using it as a single processor, and if you are using it as multiprocessor, then multiple processors are used, then you can use the maximum mode. So depending upon the value of this pin, for example, if we have this pin is set at plus 5 volt, then it will enter into the minimum mode, and if it is grounded, it will be used as the maximum mode. So depending upon the type of functionality needed, one of these two modes will be activated. Next pin is the bus high enable or status line, pin 34. So during the first clock cycle T1, microprocessor will use this pin to send out bus high enable signal, and in the next clock cycles it will send out logic 0 on S7 as status information. So for first clock cycle T1, it will be used as bus high enable pin, whereas in later clock cycles it will be it will send out logic 0 on S7 as status information. So it acts as extra status line, and it is used by 8087 numeric coprocessor to determine whether the CPU is 8086 or whether the CPU is 8088. So next pins are pins number 35 to 38. These are address line most significant bits of the address line, and for from A16 to A19. So the 16 bits of address are already acting as a are already there in the AD0 to AD15, which are multiplex lines, but these pins will be used to transfer the most significant 4 bits of memory address during the first clock cycle T1. And in 8086, it is used to send out the address for assessing input output ports, and this information will be 0 during the T1 phase, because the address input output port address in 8086 are only 16 bits. If you remember the physical address calculation formulas, we have extracted the 16-bit addresses from the segments, and we have introduced or added implicit to it to make it a 20-bit address. So this is the 4 bits of addresses which are 0000 during first machine cycle, because 8086 is sending out address for accessing input output ports, and this information pins will be 0 during T1, because input output port addresses in 8086 are only 16 bits, and in the later clock cycles these pins will send out S3 to S6 status information. So S3 and S4 pins can be used to indicate the segment register. Which segment is to be used for accessing data will be S3 and S4. So if S3 and S4 both values are 00, then ES extra segment would be accessed, and if S3 is 1 and S4 is 0, then stack segment register would be accessed, and if S3 is 0 and S4 is 1, then code segment register would be used, or if there is input output port access, then no segment register would be accessed, and if S3 and S4 both are 1, then data segment register would be accessed, and S5 will indicate the value of interrupt enable flag bit, and S6 will always be 0 in 0 state and is not used generally. So these are the pins used for in 8086 microprocessor, right? So we'll talk about the pins which are common in both this 8086 minimum mode as well as maximum mode. So the firstly we'll talk about the minimum mode pins, how these pins from 24 to 31 acts or behaves differently for minimum mode and maximum mode. So minimum mode in we have pin number 24, which indicates the interrupt acknowledge. It is related to the INTR pin at pin number 18. So if there is an interrupt INTR activated by any input output port and there is no non-maskable interrupt at the same time, then microprocessor will finish the instruction whichever it is executed and gives logic 0 on INTA pin. So it will acknowledge the given interrupt by executing the given instruction, and in response to this the interrupt acknowledge will now the microprocessor will receive 8-bit interrupt type number from the input output port, or if we have connected any programmable interrupt controller. Next pin is the ALE pin at pin number 25, which is address latch enable. So 8086 will send out information about address on AD0 to AD15 during first clock cycle of the machine cycle, and in subsequent clock cycles 8086 will use the same pins for transmitting or receiving data. So similarly 8086 will send out address information from A16 to A19 during T1 clock cycle, and same pins would be used as status information S3 to S6 during the later clock cycles. Then how we get to how does the memory or the input output port remember address for the whole machine cycle? Because we are giving the address values in only first clock cycle, and for the rest of the machine cycle, how will it remember the addresses of the input output port or memory? So this pin is used to solve this problem. This is an output pin. So 8086 will send out logic 1 on this pin during T1 clock cycle, and then some external latch will use this signal to latch onto the information sent out by the 8086 during T1. So whatever information is latched, that will be available to memory or input output ports for the whole machine cycle. Next pin at pin number 26 would be data enable pin. So whenever there is any data transfer in 8086 microprocessor, either the microprocessor is reading or writing operation is being performed, then 8086 will give data enable logic equal to 0, and this is used to enable the bidirectional buffering during the DMA operation, direct memory access operation. So this in this signal, the pins are to be isolated from system data bus. So at that time 8086 will give the data enable signal. Next is the data transmit or receive pin, that is pin number 27. If we have connected more than few devices on the data bus, then 8086 outputs are not capable to supply enough current drive. So we will be using receivers for the same, like Intel 8286 are used to increase the current driving ability. So the data transmit or receive is an output pin which is activated in first clock cycle of the machine cycle. So if 8086 will output a logic 1 on this pin, it means the buffers are used to transmit data from 8086, and if 8086 outputs a logic 0 on this pin, then buffers are set up so that 8086 can receive data from the buffers. So it will indicate whether the 8086 will receive the data from 8086 or data from buffers is received to the 8086. The next pin is pin number 28, which is memory input or output pin, and this is an output pin. So whenever microprocessor wants to communicate with memory, the microprocessor outputs a logic 1 on this pin. So if it is set to 1, it means कि microprocessor wants to communicate with the memory, and if this logic is set to 0, then microprocessor wants to communicate with the input output ports of the microprocessor. The next pin is pin number 29, which is for write, and this is an active low output pin. So whenever microprocessor needs to write information to memory location or to any input output port, it will activate this pin. Pin number 30 and pin number 31 are related to the hold request and hold acknowledge. So 30 number pin is hold acknowledge HLDA, and pin number 31 is hold request. So HLDA hold acknowledge is related to the pin number 31 hold request. So these are used when we are using the direct memory access, and hold is used whenever there is a DMA operation which is required by some input output device. Then there would be a hold request, and the microprocessor will send the acknowledge signal on this pin number 30 for acknowledging the hold request it has received for the direct memory access operation. So these are the minimum mode pins which are used in 8086 microprocessor. Next we'll be discussing the maximum mode pins from pins number 24 to 31. As rest of the pins are same for both the modes, the basic difference lies between the minimum mode and maximum mode pins. So in this minimum mode pin configuration, we have seen that it is all related to a single processor which is interacting. So in the maximum mode pins, the pins 24 and 25 are Q status pins, Q status 0 and Q status 1. So these signals will indicate the Q status. So as you all know, we have a Q, prefetch Q in this 8086 microprocessor bus interface unit. So whenever 8086 is in control of the local bus, these signals sent out by the 8086 will allow external tracking of the instruction queue. So whenever 8086 is controlling the local bus, then there would be signals sent out by the microprocessor which will allow to track the instruction queue. So these signals are output from the 8086 microprocessor. For QS0 and QS1, there will be different Q statuses for this. For example, if Q status 0 is 0 and Q status 1 pin is 0, then there will be no instruction which can be taken from instruction queue. So all the 6 registers of instruction queue are full. And if Q status 0 is 1 and Q status 1 pin is 0, then it means first byte of opcode from the queue would be accessed. And if Q status 0 pin is 0 and Q status 1 pin is 1, then due to the branching instruction, the all 6 registers of instruction queue are either cleared or flushed. And the fourth option or fourth possibility is both the pins are set to 1. It means next byte opcode would be taken from the queue. So these signals will indicate the local bus cycle status. So whenever 8086 is controlling the local bus, then 8288 bus controller will generate bus control signals using these pins, or these signals can be sent out by the 8086. The next pin is the lock pin. So this is at pin number 29. So any microcomputer system can control several microprocessors, but if each microprocessor having its own local bus for accessing local resources, for example it wants to access local memory, then various microprocessors will be connected by the system bus. So each microprocessor can access global resources, right? So we are using this lock pin when an instruction allows a microprocessor to make sure that another microprocessor does take control of the system bus during execution of a critical instruction which uses the system bus. So if lock signal is activated, then one of the signals in the maximum mode operation, then the signal is connected to the external bus controller, which prevents any other microprocessor from taking control of the system bus, because at a time only one processor can microprocessor can have control of the system bus, which is a shared resource. So there would be a lock pin which will help in identifying which microprocessor is using the system bus or is accessing the system resource, and others would be locked out. So next pin is pin number 30 and 31, and these are for request or grant operation. So these are input output pins for 8086. They can be used as input as well as output. So they are active low pins. If they are without any connection, then there would be logic 1 set to it, and which will be termed as an inactive state. So if this pin is set to 1, it means they are in the inactive state and there is no connection. So if these pins are used for taking control over the local bus, and if bus request comes at the same time from two different local bus masters on the pins, then bus signal will be granted by 8086 on ARC request 0 or grant 0 pin. So this is because pin number 31 has higher priority than. So whenever we are using the master slave configuration, then it will be used to set the request and grant option, and request grant pin number 0, that is pin number 31, has higher priority than request 1/GT1. So pin number 31 has higher priority than pin number 30. So these are the pins which are differently used in both minimum and maximum mode. So next we will be studying about the timing diagrams of both minimum and maximum mode configurations, which we will be covering in the next class.